Now that I have my next state table, I can move on to create my Boolean equations for all of the flip-flop inputs. Starting with J0 and K0, I can actually see that there is a common pattern repeating here, and that their values actually line up directly with X. So here I've put their Boolean equations just equaling right to X. For J1, K1, and J2, K2, it'll be a little more complicated, and so I'm going to make some K maps. So starting off with J1 here, just for example, I looked for wherever J1 was outputting a high value, only two places, found them there, and created the equation for J1. And now I'll complete the other equations. I've completed the rest of the Boolean equations for my JK flip-flops for J1, K1, and J2, K2. In addition, I've created the equation, the Boolean equation, for our final output Z. And I was able to make use of some of our don't care conditions, such as with K1 up here. So now that I have these, I can finally implement our logic circuit. Now here I finally have my LogicWorks circuit complete. So I have my clock input X, and then as well as the set input for each of these. It took me a few seconds to figure out why it wasn't working, because I need that initial input. I have the equations for each of my JK inputs down here. I only have 1 and 2 and Z because for these first three was just X, so I can put that right in. And then each of these feeds into here, and amazingly, it actually works. It's crazy. So it's on the negative edge trigger, so going from 1 to 0 counts up with an input of 1 until finally it gets to 8 cents. And now that we're on 8 cents, we get a high output of Z. Our gumball drops. Incredible. And then one more, and it resets to 0. And if we have a few cents in and we don't put any more, it will not count up anymore.